What's going on, guys? In this video we are going to see how to determine the absolute extrema of a two variable function. Here we have a two variable function, also we have the region. But before we go for this one, let's look at the steps. Now to determine the absolute extrema, first we find the critical points. To find the critical points, we take the partial derivative of this function with respect to x and also with respect to y, and we equate that one to 0, and that's going to be one of the, from that we find out xy value, and that one is going to be our critical point. And also if we have a condition that partial derivative does not exist, that's going to be also a critical point. Okay, now after we find the critical point, we go to the next step, that is determine the max minimum value of f of xy on the boundary of the specific region. Now here we look at the corner points and we find the values. Okay, we plug this corner points value in this function and we find the values, and also we go along this path and also find the values, and after that we compare all of these values and we look at which one is greatest, and greatest one is going to be our maximum, absolute maximum, and the lowest value is going to be the absolute minimum. Now let's start with the critical point, right? Now we are going to take the partial derivative. Also let's look at the region. Here this region says that x is between -1 and +1, and if you look at this one, this is -1 and +1. Okay, and also this one says y is between -2 and +2, and you can see that y is +2 and here we have -2, and this is our region. Now let's look at how we are going to take the critical points. To do that, we are going to take the partial derivative. First we are going to take the partial derivative with respect to x, so we treat y as a constant. Here we are going to have y, and this is going to be 0, so fx is equal to y, and if we take the partial derivative with respect to y, we treat x as a constant, so this is going to be just x, and here we are going to have 2y, and we set these two equal to 0 and find xy values. Now this is directly giving the y value. Now we are going to plug this y value in this equation to find the x value. Now we can see that 2 times 0, that's going to be 0, so x is also going to be 0. So from this one we see x is 0, y is 0, so this is our critical point. 0, 0 is our critical point, right? Critical point. And if we plug this critical point in this function f0, 0, that's going to give us 0. So this is one of the point. Now let's look at the second point. Now we are going to go to this region. Now let's start with the corner points. Now let's start from here. So first we have, this one is x is -1, y is 2, so -1, 2, and this corner point x is 1, y is 2, f1, 2, and this corner point x is -1, y is -2, so f -1, -2, and this corner point we have x is 1, y is -2, so f1, y is -2. Now we are going to plug these values in this equation to find out our function value. Now here we know that x is -1, -1 times y, that's going to be 2 plus 2 square, and if you calculate this one, 4 minus 2, that's going to give us 2. And for this one we know that x is equal to 1, y is equal to 2, and here we have 2 square, 4 plus 2, that's going to give us 6, and here we have -1 times -2 plus -2 square, that's going to give us -2 times -1, that's going to be +2, and +4 here, that's going to give us 6 again. And the next one we are going to have is f of 1 minus 2, 1 is going to be x value, and y value is -2, and here we have -2 square, and this is going to be -2, here we are going to have 4, 4 minus 2, that's going to give us 2. Now these are our corner points. Now let's go along this path. Let's say we are going to go, this line is x is equal to 1, right? Now we are going to take this path, along this path, let's say along x is equal to 1. So when we go along x is equal to 1, we bring this equation and we plug x is equal to 1 in this equation. Now instead of writing f of xy, I'm going to write z. Z is going to be equal to y plus y square. I just plugged x is equal to 1. So we get this equation, right? Now y plus y square, now we are going to use the previous calculus technique to find out the values. Now if you remember that we take the first derivative and equalize to 0 to find out the critical points. Now I'm going to do the same technique. If I take the first derivative of this function respect to y, this is going to be just 1, and here we're going to have 2y, and I set this one equal to 0. From this one we can solve for y, and y is going to give us negative half, because I move this negative 1 to this side, that's going to be negative 1, and then I divide this one by 2, so that's going to give us negative half. And if y is negative half, and we know the x is equal to 1, so our function value is going to be f negative, actually 1 negative half, because x value is 1, y value is negative half. Okay, now let's go along this is along x is equal to 1, and if we go along x is equal to negative 1, this one, okay, x is equal to negative 1, let's see what happens. X is equal to negative 1, here we are going to plug negative 1 instead of this x, so let's say z is equal to negative y plus y square. Now if we take the first derivative of this function, this is going to give us negative 1, and here we are going to have 2y, and now we are going to equate this one to 0. From this one we can say this is going to become positive 1, so we get y is equal to positive half, and x is negative 1, y is positive half, so our function value is going to be f1 half. Okay, negative 1 half. Now we are going to plug this one in this equation to find out what we get, and from this one you can see if x is 1 times, I need some space. Now let's get rid of this part. F is equal f1 negative half. Okay, f1 negative half. Now we are going to plug this one in this function, so this is going to be just 1 times negative half plus negative half square, so this is going to be 1 over 4 minus half, 1 over 4 minus half, and if we take 4 as our common denominator, this is going to become 2 over 4. 1 minus 2 over 4, that's going to give us negative 1 over 4. Okay, and let's look at this one. If we plug, now let's get rid of this part. Okay, let's get rid of this one, and let's continue here. This one we found out x is negative 1 and y is half. Now we are going to plug this one in this equation. X is negative 1 and y is half, and plus y square, that's going to be half square. From this one we get negative half plus 1 over 4, and this is going to be negative 2 over 4. So 1 over 4 minus negative 2 over 4, that's going to give us negative 1 over 4. So this one also negative 1 over 4, this one also negative 1 over 4. So this along this x is equal to negative 1 and x is equal to positive 1 path. Now let's look at this path. If we take y is equal to 2 path and y is equal to negative 2 path. Now let's say we are going to along y is equal to 2 path. Now if we plug y is equal to 2 in this equation, this is let's say this is z again. Z is equal to, if y is equal to 2, we are going to have 2x plus 4, and if we take the first derivative of this one, this is going to turn into, we are taking the respect to x, so this is going to turn into 2 plus, this is going to be 0, so just 2, and we cannot equate to 0 because 2 is not equal to 0, so this way is not possible, so this path does not exist. Now let's look at this one. If we go along y is equal to negative 2, this is going to be also same case. We are going to have z is equal to, if we plug negative 2 instead of y, we are going to have negative 2x plus 4, and if we take the first derivative, this is going to become negative 2 and this is going to be 0, and negative 2 cannot be equalized to 0, so this also not possible. So these 2 points is not possible. So these are the values we have. Now let's compare everything. Okay, Now let's bring everything together and compare. Here the highest value is going to be the maximum local absolute maximum, and the lowest value is going to be the absolute minimum. Now first we have the critical point. Let's skip that one, but let's get rid of this part. Okay, I'm going to list everything. So first we have these points. We know that f minus 1 2 is equal to 2, and f 1 2 is equal to 6, and we know that f negative 1 negative 2 is equal to 6, and then we know that f1 negative 2 is equal to 2, and here we have this one, f1 negative half, f1 negative half, that was equal to negative 1 over 4, and this one f negative 1 positive half, f negative 1 positive half, that was also equal to negative 1 over 4. Okay, now let's look at this one. Now critical point is not considered, or it's also considered. Okay, here we have critical point and we have everything. Now let's compare. Here we have the maximum point is 6, so absolute maximum occurs in two places. So this is our absolute maximum, and this also absolute maximum. Now let's look at the lowest value. Here we have this one, negative 1 over 4, negative 1 over 4. That's the lowest value, right? So we have absolute minimum in two places. So this is one of the absolute minimum, and this also our absolute minimum. And that's how we determine the absolute extrema in two variable functions. I hope this helps. Thanks for watching.